Bismillahirrahmanirrahim. Alhamdulillahirrabbilalamin. Wassalatu wassalamu ala ashrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Amin amin ya rabbal alamin. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. Selamat hari.
Salam Doktor.
Okay. So for today's session, I would like to continue yesterday's exercise. It is example 12.1 from Hibler textbook. Okay, so let's see. Nampak kan?
Nampak.
Nampak.
Okay. So this is the beam given in example 12.1 in the textbook. So this is a continuous beam. Okay, continuous beam ABCD. Okay, BC is loaded by UDL, and then CD okay has loaded by point load at the center. Okay, at the center. So please remember few things before we can start doing moment distribution. Okay, number one, what we should do. Okay, number one. Okay, number one, we have to calculate K. Okay, K for each member. So there are 3 K. So we will have K for AB, K for BC, and K for CD. And after that, we identify K, total K. Total K is actually K for each joint. Means that for joint B, we will combine K, AB, KB, KBA. K for each joint. BC as well. BC, BC macam ni. Okay, we have like this. Sini B, C, D, right? So yang ni kena combine lah. Kena combine K from AB. Let's say this is K1. This is K2. Okay, for determining total K at B, we have to combine K1 plus K2. Okay, to get K for C, we have to combine K2 and K3. Okay, but now in this case, we have KAB, KBC, KCD. Okay, so that is number one. Number two, we will calculate distribution factor. We will calculate distribution factor, and distribution factor equal to K divided by total K. And please remember, for far and fixed distribution, factor is equal to 0 for n fixed. So in our case, we have n fixed. Okay, at A and at D, n fixed. And then okay, third things, we have to calculate fixed end moment. And in today's example, we have fixed end moment for for BC and CD. For BC, we have UDL, and for CD, so this is BC, and for CD, we have point load. This is C and D, and the moment, okay, the moment for fixed end moment based on behavior, so it behave like this. Okay, this is for fixed end moment. Then we will start distribution. And under the table, we will have, okay, we will have to do two things. Under the table, number 4. Number 4, under the table, we have to do two things. Number 1, we have to distribute moment. Okay, we have to distribute. Moment. Okay, distribute moment. So under we label as distribution. So under this, we will distribute the moment. Okay, from the upper value. Okay, from the upper value means that for the first distribution, we will distribute the moment we get from FEM. Okay, we get from FEM. So to get the moment, what we will do is we will distribute join moment, which is opposite with member and moment, join moment times with distribution factor. This is the process. Join moment times distribution factor. Okay, the fixed end moment here. Okay, fixed end moment is actually the first member and moment. The first member and moment in the table. In the table means that we will start from member and from fixed end moment. And always remember the join moment always opposite with member and moment. Okay, so that is step number 4. Step number 5, we will carry the value. We will carry the value to opposite join, means that if we have A, B, so A value will carry to B, B value will carry to A. Okay, same goes to the other join. Okay, carry over. We have to use the factor, the carryover factor, and the carryover factor equal to 0.5 for n fixed. And in this example, all are considered fixed. Internal always fixed, A fixed, D also fixed, so we have to use all 0.5. And step number 4 and number 5 will be done again and again. It is repetitive process. So we repeat this process, okay? Repeat this process until the last distribution. Repeat. Okay, repeat this process until the last distribution, normally 5 times or 6 times. Okay, reaches zero value. Then we may stop. So does stop. Then step number 6, repeat. Okay, repeat. I put here repeat 6 distribution. Okay. Uh, okay. Number 6. Number 6. We total the moment. Total all moment in the table. Okay, total all the moment in the table. Okay, and this is equal to member and moment or internal moment. Internal moment. So this is the answer. Okay, this is the answer. Okay, so we are going to do the okay, the analysis of beam. This is the beam. Okay, this is the beam. So we do it together. We will verify the value using Excel after this. So we do it manually first. We do it manually first. Okay, this is the table. So in this table, I have actually prepared. Okay, the table. This table has row for join. There are 4 join A, B, C, and D. Okay, A, B, C, and D. Wait, I want to wait. Okay. So for join, join A, join B, join C, join D. So under row member, we have AB until DC. So there are 6 representing 6 member and moment or internal moment that we are going to determine. Okay, AB, BA, BC, CB, CD, DC. Okay, so join B consists of BA and BC. Join B. Join C consists of CB and CD. And then join D, DC only. Join A also AB only. Okay, so let's calculate the stiffness factor. Stiffness factor, remember, always remember stiffness stiffness, we have to calculate stiffness for element, stiffness for member. Means that AB and BA is the same thing. It is K1. K1 representing KAB. Okay, so to calculate this, we use the formula as we discussed yesterday. The formula to calculate stiffness factor considering far and fixed is equal to 4EI over L. And I have put EI outside. So we just put the value inside this this table. So what is the answer? It is 4EI over L. So equal, please calculate for me. We calculate together the value in the table. So for AB we use 4EI over L. This one is 4EI over L. Okay. This one also same, all same. Okay, all same because both and okay, our fixed internal always fixed. Okay, so please calculate 4 divided by 12. What is the answer? 0. Okay, it is 0.333. It is okay, 0.333. Okay, it is actually 0.333 EI. Okay, so what about BC lah, yang lupa lah nak buang ni. Okay, 0.333 as well because it is also 12 meter length, 0.333. Okay, and then CD, it is 4 divided by 8.
0.5.
So this is 0.5. Okay, 0.5. Okay, now using this stiffness factor, this is member stiffness. Now we want to calculate joint stiffness. Okay, joint stiffness. Okay, for joint B, total K for joint B, it is 0.666. And then for joint C, it is 0.833. Okay? Because we combine these two. B consists of BA plus BC. B consists of BA plus BC. That is why we total 0.333 plus 0.333. You get that? Do you get that? Understand, yeah? Okay, so same goes to C. C consists of CB plus CD. CB plus CD, so it will be equal to 0.333 plus 0.5. We get 0.833. Okay, everyone get this, yeah? Okay, next we will calculate distribution factor. We will calculate distribution factor. Actually, total K, you don't need to put inside, also can. This is just to explain to you how we get the total K. Okay, distribution factor. Okay, AB, what is the value? What is the distribution factor for AB? AB? DF for AB at N fixed?
0.
Okay, this one is 0. Okay, and D?
0.
0 as well. Okay. Okay, now we want to calculate the value for BA. For BA means that it is K divided by total K. Okay, KBA is this. Okay, KBA is 0.333 divided by total K. So what do we get?
0.5.
Okay, it is 0.5. So this one also 0.5.
0.5.
Okay, 0.5. Okay, next. Okay, for CB, CB total CB means 0.333. 0.333 divided by 0.833. What is the answer? 0.4. Okay, it is 0.4. 0.4. This is 0.6. Okay, because total DF at join equal to 1. Equal to 1 except fixed n. So we get this. So this is distribution factor value. So we will use this distribution factor. Okay, this distribution factor. Okay, to distribute moment. Okay, fixed n moment. Fixed n moment. Fixed n moment. 20. W is 20. W is 20. Length is 12. Length is 12. W is 20 eh. 12 kan. Length is 12. Okay. Please calculate WS square over 12 using 20 and 12. What do you get? What do you get?
240.
240. This is 240, 240. And based on sign convention, this will be negative. This will be positive. Okay. B at B is negative, at C is positive. So we put negative, positive 240. Okay. Put into the table. Okay. For BC. For BC, it is negative. Okay, I want to change color pen because this is moment. Okay, so FEM for BC is negative 240 and positive 240. And then for CD is point load at the center. Point load at the center. Okay, point load at the center. This is 250, right? 4 and 4. So we get PL over 8, we get back 250, right? 250. So which is negative, which is positive? CD is negative. CD is negative. Okay, CD is negative. So this is negative 250 and positive 250. Okay, everyone get this? Okay, so this is how we start. Okay, in the table. So means that in the table, what we need is only distribution factor. We can start by putting distribution factor. Okay, anyway, if you want to do like this also can. So start with K and then calculate DF, and we will only use DF whenever we distribute moment. Okay, so we will start the first distribution. So distribution. Okay, remember that FEM in the table. Okay, this FEM, okay, are the first member and moment in the table. Okay, and back to the concept, the previous concept that I have explained to you yesterday. Okay, ini. You have to know that this beam consists of these three elements. Okay, three elements. We have UDL here. We have point load like this. Okay, and we get moment, fixed end moment like this. We have fixed end moment like this. Beside member, we have joint. Beside member, we have joint. This is the joint. Okay, joint B and joint B and joint C. And what we distribute is joint moment, and joint moment always opposite with member and moment. So opposite this, opposite this, opposite this. Okay, means that if this is 240, this is also 240, but in opposite direction. Okay, this is 240, this is 240, this is 250. So this will be 240 and 250. So the moment, the join moment is actually based on this. Okay. Okay, this will be the join moment. This will be the join moment. Okay, join moment. Join moment for B. What is the value? Positive 240 or negative 240? Positive or negative?
Positif.
Positive. 240 positive. Okay, for C, join C. It is 240 minus negative 240 plus 250. Positive or negative? It is 250 minus 240, right? So the answer is positive. Positive, right? Positive. So
Yes.
this is actually behind the scene, behind the table. Okay, behind the table. Because in the table, okay, so join B means we have to find total moment at join. Total moment at join B, is 0 plus negative 240. Total, but total moment is negative 240. Opposite condition, positive 240. Positive 240 in the diagram just now. Positive 240. So we distribute this positive 240, not negative. Okay, so what is the answer? What is the answer? Times with distribution factor. It is total moment. It is joint moment. Joint moment times distribution factor. Okay, joint moment times for BA. For BA we times with factor BA. For BC we times with factor BC. Okay, so what is the answer? What is the answer under distribution? What is the answer? 120. It must be positive because the joint moment that we use is positive. Okay, it is 120 and 120 because the distribution factor is same. Okay, equal 0.5, 0.5. That's why we get 120, 120. So to check back whether the answer is right or wrong, make sure that whenever we plus this 1, 2, 3, 4, these four values must equal to 0. Must equal to 0 to remain equilibrium. To remain equilibrium. So these four values must equal to 0 because we got this from 0, 0 plus negative 240. Okay, 0 plus negative 240, join moment, change sign, 240 times factor 0.5, 120, another one also 120. Okay, and these four values, when we total, okay, it must be 0. Okay, then we move to the next one. Okay, total moment. Total moment, 240 plus negative 250. Total moment,
-10.
negative 10. Change to join moment,
10.
10. Times factor, times factor.
4.
4. 4.
Okay, times factor equivalent to 4. Okay, and then times factor for CD, 6. Okay, it is 6. Okay, so this is the process. This is the process under distribution. Under distribution. So there's no value, there's no moment, distribution moment at DC because the factor is 0. Kat sini, because factor is 0. So negative 250 times 0. So we remain as blank. Okay, like this. So this is how we write the answer in the table. In the table. So 0 value, we don't need to put, leave it blank except distribution factor lah. Okay. So move to carry over. Move to carry over. Actually, okay, ni dia punya boundary. This is the boundary. Boundary between join. Okay, boundary between join. So we need to carry over the moment, okay, by considering the factor, and the factor is 0.5 because of n fixed. Okay, so we have to carry the value like this. Carry the value like this. Okay, carry like this. Okay, we have to carry the value. Okay, cross boundary. Okay, factor is 0.5, means that we divide by 2. We divide by 2. So what do we get? 120 divided by 2 is
60.
60. Okay. So for BA, no value. Leave it blank. Okay, next value. For BC. BC is 4 divided by 2. 2. Okay, again 120 divided by 2, 60. And then 6, and then 0, and then 6 divided by 2 is 3. Okay, this one complete one cycle. Okay, so what we need to do next is repeat the process again. Okay, repeat the process again. So we continue. Okay, total moment 0 and 2. Total moment times with 0.5. What do we get?
1.
1 or negative 1?
Oh, negative 1.
Negative 1. Negative 1 for both. Okay. Okay, next. Okay, next value is, okay, it is 60 plus 0 times with 0.4. What do you get?
Negative 24.
Negative 24. Negative 24 and negative?
36.
Yes, negative 36. Okay, clear? Clear. Okay, so then we repeat carry over again. Okay, what is the value? Negative 0.5. Negative 0.5. Negative 12. Negative 18. Okay, clear? Okay, repeat again distribution. Repeat again distribution. It is 0 and negative 12 times with 0.5. So what do we get?
6.
6.
6.
6. Because total must be 0. It must be positive. So joint moment is positive 12. Okay. Okay, next. 0.5 and 0. 0.5 and 0 times with factor 0.4. So we get positive
0.2.
0.2 and 0.3. Okay? Carry over again. Carry over. Okay, carry over. So what do we get? So this is 3. This is 3. This is 0.1. Okay, this is 0.15. Okay, get that? Okay, yeah? Okay. Then continue distribution. Continue distribution. Okay, it is 0 and 0.1. What do we get?
Negative 0.5.
Negative 0.05.
0.5.
Negative 0.05. Okay, next one. It is 3 and 0. We get negative
1.5.
Is it 1.5? The factor is
Negative
0.4?
1.5. No,
Negative
no, no,
1.5?
no.
1.2. Negative
1
1.
1.2.
Negative 1.2.
Another one? Negative?
1.8.
1.8. Okay? Okay. Then continue. Carry over again. Okay, carry over again. So what we get? Negative 0.025.
0.25.
This one also negative 0.025. Okay, this is 1.2, 0.6.
6.
So this is 0.9.
9.
Okay. Continue. Okay, continue. Distribute again. What we get?
0.3.
Yes,
0.3.
0.3. Okay, 0.025. What we get? Positive?
0.01.
0.0.
1.
Another one? 1.5.
1.5.
1.5.
0.015.
0.015. Okay, carry over again. What do we get? 0.15. Here also 0.15. This is 0.005. Last one? 0.075.
0.0075.
0.00075.
5.
Okay. Okay, you must stop at distribution. Cannot carry over. Last one must be distribution. So we distribute again. We distribute again. So what do we get? It is 0. Negative 0.
Negative 0.0025.
0.025. Okay, same. Okay, 0.15 times 0.4. What do we get?
Negative 0.06.
Another one. 0.0.
09.
Okay. Okay, basically, whenever you meet 0.0 something. So that's why I put here, this is actually a distribution number 6. This is distribution number 5. Okay, when to stop? Stop whenever the moment reaches 0. That is the statement in the textbook. Stop whenever the moment reaches 0. So basically, we may stop whenever we find 0.0 something. So actually we can stop at distribution number 5, and if we continue, we can continue to distribution number 6. So we get all 0.0. Okay. Then what should we do next? So the last step I mentioned here, total all moment in the table. Okay, total all moment in the table means all moment in the table we total start from Start from we
Fixed and moment.
Yes, fixed end moment. Start from fixed end moment, total all the moment. Okay, now we want to calculate end moment for AB. Okay, please calculate. It is 60 minus 0.5 plus 3 minus 0.025 plus 0.15. So what is the answer?
62.625.
62.625. Okay, next value. Okay, next value is 120, negative 1, 6, negative 0.05, 0.3, and negative 0.0025.
125.248.
Okay. 125.248. Okay, check another one. Okay, another one is BC. Okay, BC. Okay, negative 240 plus 120 and then plus 2 minus 1 minus 12 plus 6 plus 0.1 minus 0.05 minus 0.6 plus 0.3 plus 0.05 minus 0.025. So what do you get?
Minus 125.248.
Minus 125.248. Okay. Okay, next for CB. For CB, okay, it is 240, 240 plus 4 plus 60 minus 24 minus 0.5 plus 0.2 plus 3 minus 1.2 minus 0.025 plus 0.01 plus 0.15 minus 0.06.
281.575.
575. Okay, 281.575. Okay, next for CD. For CD, okay, start with negative 250 plus 6 minus 36 plus 0.3 minus 1.8 plus 0.015 minus 0.09. What do you get?
Negative
281.575.
Same value, right? 281.575. Okay, last one, DC. Okay, start with 250. 250 plus 3 minus 18 plus 0.15 minus 0.9 plus 0.075. Okay, what's the answer?
234.258.
258. 234.258. Okay, this is what we call as moment distribution method. Okay, so the moment that we get, the total moment that we get, the last value, okay, the summation moment are the answer. This is called as internal moment or member end moment. There are six value. There are six value. Okay, and then these two value equal to 0. These two value also equal to 0 to represent back moment at roller equal to 0. Kan, moment dekat B is equal to 0 because kat situ roller, right? When we combine, it will equal to 0. Okay, so this is the answer. Okay, this is This is moment distribution method. Do you understand?
Yes.
Okay.
Okay. So this n moment represent 6. Okay. So this is UDL, this is point load. Okay. So 62.625 means this value clockwise direction because the sign convention is clockwise. Okay. 125.248, 125.25. Positive means the moment is in this direction. Okay. Negative 125 means negative in this direction, counterclockwise, because we refer back to sign convention. Sign convention is clockwise positive. Okay. And then next value is positive 281.575. This is positive value. And then negative, and then positive 234.258. This is positive. Okay. So this is actually internal moment. Internal moment. That is why there is a moment distribution method is very, very important, because from the end moment that we get from the table, we can draw the bending moment diagram. Okay. So from this, we can actually have the bending moment diagram. It is like this. Okay. So in the next session, but not in class session, I will do one session just to discuss on how to analyze beam to identify the shear value, so that from that we can draw shear force diagram. Because in bending moment diagram, if there is maximum moment, that maximum moment can only be determined by using the area of shear force diagram. But now I just want to show to you from this end moment that we get from table, we can actually sketch the bending moment diagram based on the moment direction. Based on the moment direction. So it is actually like this. Okay. Bending moment for AB is like this. Bending moment for BC, it may be like this. Okay, because this value we cannot identify yet, because it is come from shear force diagram. Whether it has maximum moment, or whether it is not, we have to identify the shear force diagram first. If the shear force diagram is trapezium, means there's no maximum moment. Maximum moment occur whenever there is intersection in the shear force diagram. Okay, yang tu yang saya akan buat another session untuk explain how we analyze shear forces, means the vertical reaction, so that from all the reaction value, we can draw the shear force diagram. Okay, and then next one is CD. CD. So CD. Okay, the position based, we just need to refer the arrow. You just need to tengok kat mana arrow tu is located. For example, arrow ni tunjuk kat sini kan. So point dia kat situ. Arrow yang dekat BA, position dia tunjuk ke bawah kan. So that's why bending moment diagram is like this. Okay, it's like this for AB. When there is no UDL, when there is no point load. Okay, for UDL, BMD is curve line. Okay, cuma we do not know whether it is like this or it is just like this. Because these two conditions occur when in different shape of shear force diagram. Kalau yang kat bawah, ni, yang ni kalau from shear force diagram, you dapat trapezium. Trapezium pada shear force diagram means yang bawah ni. Tapi kalau pada shear force diagram you dapat macam ni tau. Shear force diagram kalau shear force diagram you dapat macam ni. Okay, ini shear force diagram. So yang dua-dua type of shear force diagram ni, you memang kena kena do some static equilibrium, some calculation using static equilibrium, identify the vertical reaction at A, B, C and D. Sebab A, B, C and D tu kan ada AY, BY, CY, DY. So kena identify AY, BY, CY, DY dulu. Then baru boleh draw shear force diagram. So from shear force diagram tengok dapat mana satu. Kalau dapat yang atas tu, so dia ada maximum moment. Kalau dapat yang bawah trapezium, dapat yang kat bawah tu je. So there is no maximum moment. Okay, yang last one tu is point load at the center. So at the center means memang ada maximum moment dekat situ lah. Okay, because kalau dekat center macam ni, shear force diagram dia akan dapat macam ni. Shear force diagram. Okay, when shear force diagram macam ni, we will get bending moment diagram like this. Okay, and value dekat tengah-tengah ni is the area of this. Sama jugalah value yang ni, area of this. Okay, so yang ni nanti saya akan tunjuk detail in another video, Yang ni I want to verify. Using Excel. Yang ni tadi. Okay, using Excel, as I mentioned yesterday, using moment distribution method ni, it is very easy to apply because we can formulate it into Excel. And using Excel, once we have set all the formula, then we just need to copy paste until we get zero value. So let's do that. Okay, Excel. Okay. It doesn't matter. We open new one. Okay. This is AB, BA, BC, D, CD. Okay. Okay, now is distribution factor 0, 0.5, 0.5, 0.4, 0.6. Okay, and then fixed end moment. Fixed end moment to negative 240, negative 240, 240, and then negative 250, 250. And then the first distribution, we just need to set the formula. The first distribution, it is 0 plus negative 240 times with distribution factor. Okay, I set the formula again. It is 0 plus times distribution factor for BC. Okay, we get 120, 120. Okay, this is the same like what we have done just now. Okay, this is 240 plus this times with factor 0.4. Okay, and then another one times factor 0.6. 0.6. Okay, so carry over. So it is 120 divided by 2. Okay, divide by 2 is 4 divided by 2 and 6 divided by 2. Okay, so then I just need to copy this. Okay, this is second cycle. This is the third cycle. Okay, this is number 4. This is number 5. Okay, and number 6. Number 6. Okay, stop at distribution. So this is distribution. Number 2, carry over. Distribution, carry over. Distribution number 4, carry over. Distribution number 5, carry over. Distribution number 6. Okay, this is end moment. End moment. End moment. So total start from fixed end moment. So this is the answer. Get the same? Is it the same, right? Is it the same value? Same value.
Yeah.
Okay, same value.
Yes.
So you can do you can set the formula in Excel to verify your calculation. Okay, so this is the answer. So that is why I said yesterday this is very famous topic. And then you will do this, you will again use moment distribution method, apply this whenever you want to identify the crack in the or the deflection in the structure. Okay, because you need to draw the bending moment diagram, and to draw the bending moment diagram you will normally, okay, students normally do moment distribution method because it is very easy to apply, repetitive process, and can be set using Excel. Okay, using Excel. What most important, you understand the concept. That is why I explain, okay, in the table like this. Okay, so please make sure you repeat watching this or try do this again. Okay, I have actually sent to everyone under your class notebook. Under your class notebook, I have actually put your formative exercise, actually the same. It is just like the same. Okay, the same thing. Okay, for formative 1.1, A and D fixed. Formative 1.2, 1.2, I put one roller. Okay, one roller. Remember the roller, the end roller or end pin. Okay, the factor is 0. The factor is 0. So try to answer this. So this is your formative exercise. Okay, before you do this. Okay, this is summative 1.1. This is part of your assignment 5%. Okay, please do it correctly and try to get full 5 marks. Okay, do you have any question? No, eh? Okay, I just want to tell you 1 minute. Okay, under your student notebook, okay, class notebook, if you see here, you will find that you have folder name, okay, student profile. Student profile. So what I want you to do here is, I want you to screenshot your SIM punya front page tu, yang ada nama, detail-detail, nombor telefon semua kan. Siapa PA, apa your CGPA kan, ada you punya summary of CGPA every semester tu kan. That front page tu tolong screenshot and letak dekat sini. Okay, letak dekat sini, everyone. So don't worry because your friend tak boleh tengok. So it's only you and me. Okay, that is very very important for me to see your what do you get previously. So at least I know okay, I know which part to highlight. Okay, especially okay, this is very very important for me. This is very very, very important. I want to know your previous mark, especially for solid mechanic and 424 determinate structure. Okay, and I want to know your PA as well. So please do this, put into this. Okay, put into student profile, screenshot and put into this. Okay, another thing. Okay, another thing, I will actually give you the diagnostic test. Okay, diagnostic test. It is just about 30 minutes. 30 minutes. Quiz. Okay, 30 minutes quiz, diagnostic test. So every semester, in the beginning of semester, every student need to answer diagnostic test. Okay, actually it should be done last week. But we have to postpone to this week. So is it okay if the diagnostic test I assign to you this Sunday at 3, half an hour? Is it okay with that?
Okay, Ate.
Okay,
Okay.
okay. It is just revision to what we have learned previously under solid mechanic and under discriminate structure. Okay. So thank you very much. I have actually uploaded the previous recording. I have uploaded 3 videos. Okay, the team's recording for group B and group H, group 5B and group 6H. So please okay, because some video, so all the video is not the same. Okay, ada yang saya highlight dalam group B, saya tak highlight dalam group H. Macam ni lah, yang ni yang saya buat dalam table ni, saya tak bincang dalam group B semalam. So saya buat in detail dalam your group. So kalau boleh tengok baliklah semua video tu, combine balik. So insyaAllah you will be more clearer. Okay, so that's all for this session. Sudah pukul 1. Thank you very much. Thank you very much. Thank you for your participation. So please make sure you do formative assessment first before you submit summative. Because formative assessment tu is for me to know your level of understanding. Okay, you submit dulu formative. Okay, submit formative tu untuk saya nak tengok level of your understanding. Kalau and then saya akan saya akan komen kalau ada pembetulan. Okay, if okay, then you can proceed with submission of summative 1.1. Okay, so that's all for today's session. Semalam kita gambar tak? End of session. Ada tak?
Tak.
Tak ya? Okay, so kita buat sekarang kejap. Okay, I stop recording first. Thank you. Yang ni.